Hi everyone, I'm Dean Lovewell, the Metals Market Manager here at Instron. And in this video, I'll be providing some insight into ASTM A615, which covers deformed and plain carbon steel bars for concrete reinforcement. This standard refers to multiple aspects of rebar, including chemical and dimensional characteristics, as well as the measurement of mechanical properties. The part I'll be discussing today is the measurement of tensile strength, since this is the area where we see the most questions. Today, I'll be testing a size number 4 specimen of grade 40 rebar on this Instron 300 kN frame with hydraulic wedge action grips. Because rebar brakes pack a lot of energy, you'll want to make sure you're using a testing machine and grips that are sufficiently rated and specifically designed to handle this type of testing. Otherwise, the vibrations and shock waves can cause damage to critical components. For your jaw faces, you'll want to choose a configuration that accommodates the typical deformations of your product and won't hold on to the scale after each test. A less aggressive tooth pattern encourages the scale to drop freely and prevents premature failure of the specimen by not biting into the metal too much. It's good housekeeping to remove any debris or scale from your grips and machine between tests. But you should also be using a test frame like this one, which is designed to prevent debris ingress. You'll also need an appropriate extensometer, either a clip-on like this one, or an automatic version like our AutoX here. To determine the appropriate speeds and changeover points, ASTM A615 references ASTM A370 and E8 test control methods. These standards permit controlling by stress rate, strain rate, and crosshead displacement. I will be testing in crosshead displacement control, and I've determined the test speed so that the strain rate achieved at yield is within the requirements of the standard. This is important for performing a valid test, as the yield strength is a strain rate sensitive property and can be significantly influenced by straining too fast or too slow. Before starting the test, we want to make sure we program a preload to properly seat the specimen. In addition to ensuring that we don't have any slippage, this process takes up any compliance in the load strain, ensuring that the load applied during our test is only going to the specimen. If this step is skipped and you're using an extensometer, whether an AutoX or otherwise, you may see negative strain as the specimen tightens or as compliance is taken out of the system. By having this take place during the preload, we avoid this portion being recorded in our stress-strain plot. A best practice for choosing your preload is just less than 5% of your expected yield strength. So for this grade 40 size number 4 specimen, I've chosen to preload the specimen up to 2000 psi. Once the preload is met, our crosshead displacement control will take over, and we'll see a nice proportional line as the specimen is stressed in the elastic region. It's possible to get some non-linear behavior here, especially in the beginning of the plot if the specimen wasn't completely straightened before the test or during the preload. Now that the rebar has yielded, this is the point at which you can remove your clip-on extensometer. In our case, the AutoX automatically detaches and moves out of the way. Now that the test is complete, we can remove the specimen and return our crosshead to the start position, ready for the next test. And that's a quick look at ASTM A615 as it relates to the tensile testing portion of the standard. To learn more about A615, I recommend checking out the standards page on our website and consulting the standard on ASTM.org before testing. Thanks for watching.